go. Our objective for today, before I get there, let me just show you a quick map of where we're at in regards to systems. To solve systems of linear equations, there's three different ways. The first one we already did, which was by graphing. Remember that? Yes. Yesterday we did by substitution, where we needed to solve one of the equations for one variable and substitute into the other. Today we're going to solve what we call using the method of elimination. Other people call it combination and other people call it addition. Call it whatever you want, but this is what it is. So today we're going to call it elimination method. Are we there? So this is the last way that we're going to do solving systems. So our objective for today, I can solve systems of linear equations by elimination. Let's read it together. 1, 2, 3. I can solve systems of linear equation by elimination. So we're still on the same concept of systems of linear equations. So for your title, I want you to write solving systems by elimination. Solving systems by elimination as your title. Solving systems by elimination. All right, and like I said, we're still on the same concept of systems of linear equations, and we already know what they are. Systems of linear equations, we went over the definition. Two or more linear equations that have the same variable, gave you guys examples and examples, and we know that there's two or more and same variables. Today, we have, again, multi-steps. Here it goes. We have 5 different steps. For those steps, I want you to circle and underline stuff that is going to help us memorize our steps. So step 1, I want you to circle the word change. And step 1 says, change all equations to standard form. Change all equations to standard form. So an easy way to remember is change to standard form. Step 2, eliminate one of the variables by adding or combining. Eliminate one of the variables by adding or combining. Step 3, solve the remaining variable, or solve the equation for the remaining variable. Solve for the remaining variable. Step 4, substitute the value of the known variable to one of the two equations and solve for the last. So we're going to substitute the known variable, which is what we got here, and substitute that into one of the equations and solve for the last one. And at the end, step 5, write as a coordinate and check, which is something that we've been doing already. Write as a coordinate and check. Write as a coordinate and check. Okay? So we got our steps. So like I said, it's pretty lengthy, but it's very simple, and it's going to be a little bit faster than the other steps. Watch. Copy this example down. Example number 1. Example 1, solve system of equations, and here's the system. Copy this one down. Y equals negative 2x minus 5, and y equals 2x plus 13. Solve the system. Y equals negative 2x minus 5, and y equals 2x plus 13. Just copy it. I'm going to go ahead and do this one. When I ask you to copy, you copy, and then you just focus for the next step. Here it goes. Pens down, eyes up here. So step 1, change to standard form. So check this out. Everybody look up. I'm going to rewrite these side by side so I can change them into standard form. Are they in standard form? No. They are in slope-intercept form. Do you guys see that? So check this out. I'm going to bring those over here, and I'm going to change these into standard. What do I need to do here to change it into standard? Plus 2x, plus 2x. These cancel. We're left with 2x plus y equals negative 5. How about this one? What do I need to do to this one? Subtract 2x to each side, and we're left with negative 2x plus y equals 13. Copy that, please. That was step 1. Step 1. All right, here we go. So, first step, change into standard form. Did we do that? Yes. Step 2, eliminate one of the variables. So check this out. This is the next step that you need to pay attention because this is the one that's going to make the whole thing work. Here it goes. Step 2, eyes up there. To eliminate one of the variables, I'm going to stack these two equations, one on top of the other. So I'm going to rewrite this one and this one over here. So pay attention. Here it goes. There they are. You see how I stacked them? Okay, now look at them. Don't say it out loud, but by looking at them, we can see that if I was to draw a line right here, and if I wanted to combine stuff here, I can see that one variable is going to eliminate. How about 2x minus 2x becomes what? 0. So this one eliminates. What do we have left? 1y plus another y becomes what? 2y, 13 minus 5, 8. So this is 2y equals 8. Copy that, please. Boom. All right, here we go. Let's go over our steps. Step 1, did we change into standard form? Yes. Step 2, did we eliminate one of the variables? Yes. Let's look at step 3. We're going to solve for the remaining variable. Solve for the remaining variable. How can I solve this? Divide by 2. Divide by 2. Divide by 2. We're left with y equals to 4. Copy that, please. So once again, standard form, yes. Eliminate one variable, yes. Solve for the remainder, yes. Step 4, we're going to substitute that value into one of the equations and solve for the remainder. So which equation do you want me to use? The top one. So therefore, I'm going to use this one, 2x plus y equals negative 5, but instead of y, what goes in there? The 4. So therefore, we're left with 2x plus 4 equals negative 5, and it says solve for the last variable. Can we solve this equation? Yes. Yes, I subtract 4 from each side. We're left with 2x equals negative 9. At the end, we divide by 2, divide by 2. X equals negative 4.5. Yes. Copy that, please. So, let's see. Did we change the standard form? Yes. Eliminate one variable? Yes. Solve for the remaining variable? Yes. Substitute that value into one of the equations and solve for the remainder? Yes. And at the end, it says, write as a coordinate and check. So what would be my coordinate using these two values? Negative 4.5 and 4. Copy that down. And we're going to check this, and I'm going to substitute into one of the equations. I'm going to substitute into the top one. So check this out. So I'm going to take this top equation right here and check. So let's substitute that in there. So for x, what goes in there? Negative 4.5, and then for y, 4. So substitute that in there. So what is 2 times negative 4.5? Negative 9 plus 4 equals negative 5. What is negative 9 plus 4? Negative 5. Is negative 5 equals to negative 5? Yes. Yep. Cha-ching. Yeah, the solution. Let's see. Did we change the standard form? Yes. Eliminate a variable? Yes. Solve for the remaining variable? Yes. Yes. Substitute that into one of the equations and solve? Yes. Yes. Write as a coordinate? Yes. Yes. Did we check? Yes. Yes. So that's the entire process. Very simple? Yes. Okay, so with that said, example number 2. Copy this example, please. If it doesn't fit there, do it in the back because I know some of you have like 36 to 100 fonts. So make sure you do it in the back. Here we go. Example 2. Copy this system down, please. There's a system, y equals negative 4x plus 10, and y equals 4x plus 2. All right, so let's do this one together. Let's go over our steps. Step 1 says change all equations to standard form. So we're going to rewrite them side by side and change them into standard form. So let's see. On this one, what do? Add 4x to each side, and then we're left with 4x plus y equals 10. This one, subtract 4x from each side, we're left with negative 4x plus y equals 2. Hands if you got that. Okay? From there, step 1 is done, standard form. Step 2, eliminate one variable. That means we need to write these stacked one on top of the other. Is that correct? Yes. All right? So check this out. So let's write these one on top of the other. If you just want to leave one there and bring the other one over, that's fine, as long as you have both of them stacked. So here we go. Okay, turn to your neighbor, let them know which one's going to eliminate. All right, so yes, the 4s. What is 4 minus 4? 0. That's why these eliminate. And we're left with 2y equals 12. So far, so good? Step 3, solve the equation for the remaining variable. Divide by 2 both sides. Y equals 6. Hands if you got that by yourself. Okay? So let's see. Did we change standard form? Yes. Eliminate a variable? Yes. Solve for the remaining variable? Yes. So step 4, we're going to substitute into one of the equations. I usually use the first one, or the one that requires less steps. So therefore, I'm going to take this first equation, 4x plus, but instead of y, what goes here? The 6. So that substitutes in there. So we're left with 4x plus 6 equals 10, and it says to solve for the last variable. So we subtract 6 from each side. This cancels. We're left with equals 4, and at the end we divide by 4, divide by 4, x equals 1. So far so good. And the last step, step 5, write as a coordinate, and our coordinate is what? 1, 6. 1, 6. There it is, and all we have to do is check. Let's check this. So I'm going to use the top one. So I'm going to bring down the 4x plus y equals 10. And instead of x, I'm substituting y. Instead of y, 1. Instead of y, I'm substituting 6. So this becomes 4 times 1 plus 6 is 4 plus 6. What is 4 plus 6? Is 10 equal to 10? Yes. Now remember, for systems, this has to be true for both equations. So right now I'm only checking one, but do we know how to check the other one? Yes. Okay. All right. So far so good. Show me with your fingers how comfortable you feel with these. Okay. I see some 4s, some 5s, 3.5s, 4.5s. Okay. Now, like I said, this is a little bit of a simpler process than the other ones that we've done. Is that correct? All you have to do is get through the first 2 parts and you're done. Okay. The rest of them is a piece of cake. All right. So with that said, that was example 2. Example 3. Copy this next one down, please. Example 3. Here it goes. Example 3. The system X. Give me a second. All right, here it is. X minus 10y equals 60, and x plus 14y equals 12. All right. Before you go and finish this one off, let me just ask a couple of questions so like that we can think about it. Here it goes. By looking at it, we would have thought that we would eliminate the x, right? But what do you notice? That they're both what? Positive. So therefore, I go to the y's. That means I'm going to eliminate these because one of them is positive. But wait a minute, but they have different numbers, and if I go 14 minus 10, I'm still left with 4y. So none of them eliminate, right? They don't, because what is x plus x? 2x, and this is 4y. So therefore, you're saying, man, if only this one would be a what? A negative. Well, guess what? We can change this one, but we need to change the entire equation. So what can we multiply to make this a negative? Negative 1. Copy that and distribute. So this becomes negative 1x. To make it a negative, you just multiply times the negative, the entire equation. Negative times 14y, that's negative 14y, equals negative 1 times 12, that's negative 12. Okay? So far, so good? Yeah. All right. So now, at that point, we're no longer going to use this equation right here. Everybody look up to the screen. We're no longer going to use this equation. So if I wanted to get it out of the way, I'll just erase it. I don't have to erase it. You just make sure you go over it. However, look at these two. Can we eliminate a variable now? Yes, because they're both in standard form. So now I'm going to eliminate the, oh, wow. I'm going to eliminate the x's. Is that correct? These cancel. What do we have left? Negative 10y and negative 14y becomes negative 24y equals, what is 60 minus 12? 48. And solve for the remaining. So step 1, standard form, yes. Step 2, eliminate a variable, yes. Step 3, solve for the remainder. What do we do? Divide by negative 24, divide by negative 24. We're left with y equals negative 2. Okay? So now, from here, so we did change into standard form. That was already done. Eliminate one of the variables. Solve for the remainder. Substitute that into one of the equations and solve. So which one do you want to use? The top one. So I'm going to write this right here. X minus 10y equals 60. But instead of y, what goes in there? The negative 2. This one goes in here, so that's negative 2. I open up parentheses because the 10 is multiplying it. So I'm going to write x minus 10 times negative 2 equals 60. So what is negative 10 times negative 2? Positive 20. Bring down the x and the equal and the 60. Now we can solve for the remainder. Subtract 20. Subtract 20. X equals 40. And step 5, we write it as a coordinate. So my solution is negative 2. That's our solution. And let's check. I'm going to use the first equation. X minus 10y equals 60. Let's check to see if it's true. This is x. This is y. So for x, I'm going to substitute 40. And for y, I'm going to substitute negative 2. And I bring everything else down. The negative 10 equals 60. What is negative 10 times negative 2? Positive 20. Bring everything else down. What is 40 plus 20? Is 60 equal to 60? Yes. Therefore, just to double check, we would check the second equation and do the same thing, and that's how we check to make sure it is a solution. Okay? Now, I'm not asking you to write a statement. Notice on this one. But I do want you to understand, what does this mean? What does this mean? Think about it. Why is this a solution? Think about it. Why is this a solution to the system? Okay, tell your neighbor, why is that a solution to the system? Very good, I heard. Because if I was to graph both equations, this is the point where both of them intersect. Or, if I was to substitute this into both equations, it makes both equations true. Everybody remember that? That was a statement that we started writing for systems that I wanted you to understand. Is that correct? All right, and one last one. Copy this next one down. Example number 4. Example 4. There you go. Example 4. The system, negative 3x plus 4y equals 12. And the second one is 2x plus y equals negative 8. Okay, this one also requires a little bit of thinking, so pens down, eyes up here. Here we go. So you'll finish copying right now. So check this out. By looking at it, they're already in standard form. Step 1 is done. Step 2, let's eliminate. Can we eliminate the x's?
Yes. Yes.
No, because what is negative 3x plus 2? Negative 1x. We can't eliminate. They have to be the opposite number, aren't they? So now let's look at the y. Can we eliminate the y's? Pay attention. Stop what you're doing. We can't because they're both positive. However, what could this be in order to cancel this one? Negative. So that means we're going to multiply this entire equation by negative 4, and then we know what to do from there. Is that correct? All right. So for homework, pages what? 347 to 348. 1 through 25 odd. Turn in your homework on your way out, guys. Have a good one. Enjoy your homework. See you guys tomorrow.